nasa manda model tu na kiri ID na tu same word ya copy ya na kaka mun de ko ne ya ko ni ko ira ni ko ira ni ai mo ko ni da
We'll be starting the session in 2 minutes at 3:30.
ako ko mo de ko mo ko untuk ada mulai kita mo de ada mo ni ada mo de
Gomez,
ko mo ko mo
you
ko mo
can mute
apa
yourself.
mana ni
Gomez, Gomez sound, you can mute yourself.
era ko
Gomez sound, please mute yourself. Thank you. Gomez, please mute yourself.
what I want
Gomez, please mute yourself, otherwise I have to remove. Please mute yourself. Gomez, please mute yourself.
Ele não, cara, entendeu? Ele não, itu não.
Let's wait for 2 minutes more. Let everyone join. Am I audible? Polash? Please write in chat box. Am I audible? Okay, thank you. Okay, let's start this session. My name is Satyavikram Pratap Singh. I am PhD scholar at IIT Bombay, and this is the third tutorial session I am taking for your course, that is Smart Grid Basics to Advanced Technologies, and your instructors are Professor N.P. Padhi sir and Professor Premlata Jana ma'am. So before moving to this session, I request you to please interact with the session and please answer the question which I put forward. I am putting the first this question related to this storage devices of your third assignment, and please go through this 7 statements are there, and you have to tell me that which one is correct and which one is false. Please try this question. Gomez, you can turn off your camera. Please try this question. There are 7 statements are there, and you have to tell me that which statements are true and which are false. Any answer? Pulas is saying A, B, D, E, F. A, B, D, E, F. A, B, D, E, F. Any other answer other than this Pulash answer? I request everyone to please try this question. Kume, Seema, any other answers? Rajesh, Rania? You have 1 more minute to finish this question. Pulas, verify your question if there is incorrect or anything. Any other answer? If you are trying, write in the chat box that you are trying. Okay, then let's go to the solution part. There are 7 statements which I have given related to this storage devices of your third assignment, and you have to tell me that which one is correct. Let's read the first statement. First statement is saying increasing the share of variable renewable sources. Actually, that is correct. Why this is correct? Because you know the renewable energy generation is not constant. It depends upon the various physical factors such as weather condition, location, etc. So to come up with the solution of these intermittencies of the variable renewable sources, you need a certain storage devices to compensate this variability. So if you are increasing the share of this variable renewable energy sources, you need the storage devices to compensate that increment amount of this renewable energy generations. So first one is correct. Coming to the B part, to address the intermittencies of the variable renewable sources, that is also correct, which is I have told initially. Coming to third part, that is the enable electrification and decarbonization of the end-use sector, that is also correct. Why this is correct? Actually, in one sense you can say this is correct, and in one sense there is also false. What is the one sense? First is, if you see, if you increase the variable renewable energy generation, indirect way you are reducing this carbon emission which is coming from this conventional power plant. That is the indirect way. If you are saying the direct way, so that is this storage devices cannot reduce this decarbonization. Actually the problem is such that you cannot use this storage devices only. You have to use certain other resources in place, and this energy storage system must be used as a backup. So enable electrification. If you see the EV example also, if the storage devices are increasing, then they also this electrification also increasing. This is somewhat correct and somewhat false also. Coming to the D part, that is the excess variable renewable energy sources can be stored and used in a consistent and controlled manner. That is true, because you can use in the controlled manner. When there is a peak, then you can use these storage devices to mitigate that peak which is coming into your system at the evening hours. So that is also can be used in a controlled manner and the consistent way. Coming to the E option, that is the potential solution to increase the system flexibility. That is also correct, because you have the flexible manner, no, because if there is no generation of the PV, no wind is there, so you can place this storage devices to meet that extra demand which is coming from the end user. This is the most important, that is the flexible environment. Coming to the F part, that is the unique ability to quickly absorb, hold and then reinject electricity. Actually it depends upon what kind of storage system you are using. It is correct that you have to absorb, hold or then reinject electricity when it is needed, and it also depends upon the certain factor, that is the time it takes to inject this electricity when it is needed. I will show you this graph also in the coming slide, that how this is variability in the time duration comes. Coming to the G part, can be deployed and scaled close to the location of the need. Actually this is false, because if you see this PV generation at a far apart places, so you can use the storage device at that place only to store the electricity, then you can transfer to the places where there is a need. I have also given a figure in the right side. If you see, there is a wind farm is there, permanent magnet synchronous generator base, which is connected to a DC bus bar through AC DC converter. Then PV panel is there through DC DC converter, and energy storage system connected to DC bus bar through DC DC converter. And it is also connected to some induction generator also, wind farm 2, induction generator based wind farms. It is also connected to that DC bus bar. So if you see there is any kind of intermittency in the renewable will come, then this DC backup will place the power into the DC bus bar, which can be utilized by converting it to the particular AC form. And in the second figure, I have given one example of this conventional power plant. Conventional power plant, if you see, this is connected to this induction generator base and SG1, SG2, SG3, SG4. There is no certain backup is there, but if you need the power, then there is a capacitor bank for reactive power support, but the load is fixed. Load is fixed means you can apply this amount of power during the light load or heavy load condition, but you cannot increase the power which is demanded during this peak hours. So that is the most important point of this variable energy storage system. This is the second question, depending upon the various energy storage systems and their inventors and the time at which they are invented or any related statement. You have to tell me that which option is matches with the options correctly to the right side column. Please try this. I know this question is related to some memory based, but you can try some of the statements. If you give the two correct answer also, that is fine, or one, that is also fine. At least you try. If you are correctly matching the one statement also, you can write in the chat box. You are saying first is G and third is E. Okay. Any other answers? Anybody? Gomez, Umar, Pradnya, Devendra, Rajesh, Siva. Any other answers? Rajesh first of G. Okay. Any correct answers of any other statements? Okay, let's jump to that part. I will explain how you can search that. First, if you see the first statement, that Sir William Robert Grew mixed hydrogen and oxygen in presence of certain electrolyte to produce electricity and water. If you see the example of this rockets, what they use for the drinking purposes in the space itself, they use this kind of conversion also, that hydrogen plus this hydrogen plus oxygen to the water. They convert this hydrogen, they mix the hydrogen and oxygen in a certain amount to convert into water form. So that kind of the fuel cell which they use for in the rocket itself for generation of this water. This is written in the 12th NCERT itself, if you remember anything. And coming to the second part, that is French physicist Gaston Planck invented the first practical version of rechargeable batteries. If you search from the options itself, you can see that there are few options of the battery, that is a lead acid battery, nickel cadmium battery, paper battery are there. So there is few statement which can be correct for this, can be B option, D option or E option, but its correct option is lead acid battery. Okay, for the military purposes, John A, this question is in your assignment also, this John A Howell for the military application, that is the flywheel energy storage, that is Gomez's answer is correct. And this Swedish scientist, the Waldmer, invented the battery with the two metal electrode in a potassium hydroxide. If you see this hydroxide part, you can check the answer itself, that nickel cadmium will be the answer. Nickel hydroxide and cadmium based solutions they uses. Ferrier introduced the source of energy to accommodate the diurnal variations of the power dynamo. That if you see this superconducting magnetic energy storage, that is also come with the variability, that is diurnal variations of the power dynamo. If you see the next option, that is the low internal resistance is depicted here, that is inside of this supercapacitor. It has a very low resistance. And coming to the last part, that is the three scientists, that the Resnier Polytechnic Institute, New York, invented this concept of, that is the paper battery. If you see the answer, that is the reverse part, that is the first is G, second is F, third is E kind of system. So that is a memory based question. Coming to some next question, that is the, if you see in the left side, there are certain characteristics of the energy storage systems are given, and the right side in the storage energy type is given. You have to match which characteristic matches with the correct storage energy type. If you get the correct answer of any one, you can solve this question. Pola saying 4th of D. Actually this is third question for us. 4th D, oh sorry, 4th D. Okay, 4th D, that is correct for us, 4th D. Try this third question. Okay, Pulas is saying first of D, second of C, third of A, fourth of B. It means that B option. Any other answers? Rajesh, Gomez, Omar, Devendra. Any other answers? This is easy question, man. If you see the statement, okay, Seema is saying D option, Rajesh is saying B option. Rajesh, one D option is also the answer. Okay. Okay, any other answer? Gomez, Omar. Okay, let's come to the solution part. Okay, if you see the certain statement and a certain keywords, if you see the let's say the first statement, first characteristic, that is it's saying the sensible latent and thermochemical energy storage. Thermochemical energy storage. If you see this thermal is already coming into this statement. It means that thermal energy can be a option of this thermal or electrochemical energy. Okay, so mechanical electrochemical energy can be a option. If you see the second option, that is the pumped hydro gravity compressed air and flywheel energy storage. The second part, if you see, that is matches with the mechanical energy. Mechanical energy, why? If you see the flywheel energy storage system, so it stored the energy when the sudden jerk or certain energy is transferred, a certain generation is higher. So flywheel stored that, and reverse manner it will dissipate it during this operation of the demand phase. So it kinds of mechanical energy. So second of C option is correct. If you see the third option, that is the hydrogen energy storage, that is synthetic natural gas storage and the solar fuel. So third option, if you see, it is correctly matches with this chemical energy. Why? Because if you see the solar fuel or hydrogen energy storage system, there is a certain chemical bonds which you have to break for getting the energy. So that is the chemical process, the breaking of the bond and getting the energy. And coming to the fourth part, that is the battery and any other, that is a paper battery or the flexible battery kind of system. So that is also a part of this electrochemical energy kind of system. So which option is correct? Option B is correct. Option B is correct. Okay. Okay. You can take the calculator also, because the coming questions are related to the numerical based problems. I am giving 1 minute to this. Take the calculator or anything, because certain questions are related to this. Give me one. This problem is related to the hybrid energy storage system. Any answers? Now it is it visible, Gomez? Let's try this question. This question is related to this hybrid energy storage systems. Okay, Polas is saying A, C, D options are correct. A, C and D options. Any other answers? Any other options? Okay, let me come to the solution part. If you see the literal meaning of this hybrid energy storage systems, you can say that this is a kind of hybrid of certain things. Hybrid of what? Hybrid of certain energy storage system. So coming to the first statement, that is the merging two complementary storage systems, one with higher energy density and other with higher power density, makes hybrid energy storage system. That is option is correct. Why? If you are mixing this making this hybrid energy storage system, you need one system which have the higher energy density, and second system with higher power density. That is hybrid kind of energy storage system. Coming to the second part, that is the combination may be technically limited but not physically. That option is wrong. Why? Because you need to follow certain standards. Certain standard in what sense? From the technical sense also, physical sense also. Physical sense, you cannot connect any battery which is inflammable with the other solutions which are connected with the different hybrid energy storage system. So that is also the physical characteristic also should be taken into account. Coming to the C option, that is the mix appropriate features of several ESS. That is true, because you have to mix the certain qualities which is similar and which is not harm the one other form of this energy storage systems. And coming to D part, that is also correct, because it is given into this booklet also, which you have taken from the NPTEL website. That is the Varel Germany 2018 is a type of this hybrid energy storage system which combines this lithium ion and sodium sulfur batteries to balance out the frequency fluctuation. We will see this what kind of this ancillary services the battery energy storage system can supply. Coming to the next slide, that is the why we need this energy storage in our power grid. There are certain characteristics which need to be addressed in this power grid. First one is the system operation. System operation. In system operation, there are three kinds of things come. First one, that is the frequency regulation. Frequency regulation in what sense? If their PG is the generated power and PD is the demand power. So if the demand power is greater than this generated power, it means that the frequency will fall down. And in the second sense, what you can say, if PG is greater than PD, then PG is greater than PD, in that sense frequency can increase. So this kind of frequency regulation you need. Why? If the frequency is decreasing, you need certain power to inject to increase and make this frequency nearly constant or the rated value, that is the 50 Hz. And if the frequency is increasing, it means that you have to store that extra energy to maintain this frequency at a rated value at a 50 Hz system. So the frequency regulation is one of the need of this energy storage system. Coming to this flexible ramping, I will explain what is this ramping part of there in the coming slide. Currently you can just say that ramping means sudden change in power demand. If there is a certain change in power demand, then frequency, this power generation also have to ramp up in the same sense to meet this power demand. So this kind of from a lower level to higher level, it can be said as this is ramp up kind of situation is there. Same condition when the power fall down, then ramp down can be said that this power is ramped down to a certain value. level. Black start service, it means that when the sudden blackout is there and you want to restart your grid, then this kind of services also needed for this energy storage system to do in case of this black start services after the blackout. Energy shifting and the capacity investment difference, this I will explain in the further slide, and transmission and distribution congestion relief. This means that if you have certain kind of storage devices are in place, so if there are certain transmission lines are there which is interconnected, and at a one place of this grid the power suddenly got a ramp up. So if there is a energy storage system is there, then that energy storage system can supply this extra demand which is there in the grid by this energy storage system in a less amount of time. So you don't need to depend upon this far end generator for the supply demand to ramp up your power generation in form of this sudden increment in the load demand. So that is kind of congestion relief will be provided by this energy storage system. And reducing the renewable energy curtailment, which I have shown in the first slide also, that during the this renewable energy, that during the evening hours, you can use this energy storage system to supply the power. Capacity farming, I will explain this statement in the further slide, and also it increases the reduces the resilience on the digital generator. The important point is that there is a greenhouse gas emissions will reduce down by if the digital generator will not in place. So the energy storage system in indirect way increasing the reliability, that a green energy kind of system, ramping up of this concept. So coming to the next concept, that is the ramp rate, which I have shown you, which I have explained you. So there are certain statements are given, that is 6 statements are there. You have to tell me that which options are correct and which options are false related to this ramp rate. Let's try this question. If you have any doubt, you can write in the chat box related to anything. Everyone please try. I request everyone to please give the answer, because if you do not interact with these solutions, then it will be not really fruitful situation for you. A, B, C, D, F. Okay, Gomez is saying A, B, C, D, F. Okay, Polas is saying this A, B, C, D, F. Any other answer? Devendra, Kaduman, Shima. Okay, let me make you understand this concept, that is a ramp rate. Okay, if you see this curve is related to this maximum capacity versus this capacity means power level versus this time. This is the time axis and this is the power axis. If you see, there are two levels are there, that is a maximum capacity and minimum capacity is there. So if you are starting a plant plant needs certain time to start, so that is the startup time of a plant, startup time. So if your demand is at a maximum capacity, so after the startup time your plant have to ramp up to a certain level to meet this demand, this maximum capacity level. So this is a kind of startup ramp up rate. Then when you are giving the supply, then if the certain level comes, that is the minimum generation levels come, then your power plant have to ramp down. This ramping down means lowering the power from a maximum capacity to minimum capacity level is a ramp down rate. And this is the time when this minimum generation level is maintained, this time duration. And then if there is a again then ramp up cave, this is also a ramp up rate. And if the plant is getting shut down, it means that you have to come from a maximum capacity level to zero level. So this is the shutdown ramp down rate when the plant is getting off. And this is the minimum downtime after this shutdown ramp up rate. This is the minimum shutdown time up to which this power plant is in off condition. So if you see this is a power generation versus time. So what you can say about this ramp rate? Ramp rate is change in P versus change in T. Okay, if you from the first this is startup ramp rate, it means that the power max minus 0 divided by the time it taken to ramp up at the particular value. So this is the concept of the ramp rate. And there are certain other concepts are also there, that is the minimum generation load levels. It means that minimum turn down level or technical minimum in the Indian concept defined as the minimum output that the generator can sustain continuously. So because if you are turning off a power plant, so you need a certain time to bring back the power plant at a certain level. Because if you are shutting down a power plant, then it must take a startup time to ramp up to a certain level. Okay, so it takes certain time to turn on means to come up at a particular level from where you can go to a maximum capacity level. And coming to the camp rate which I have shown you, that is calculated as the capability of a unit between its maximum and minimum level. It expressed in form of this percentage. And startup shutdown, startup means when you are taking the time to move from a non-operational state to a operational state or vice versa. That is the startup time or shutdown time. And this minimum up and down time, that is the minimum length of time the plant must stay in this operational state before taking offline or the vice versa. So there are 4 concepts related to this turning on and ramping up and to maintaining and turning off this power plant. So you can say that this is the power versus time curve which can be depicted in form of this ramp rate based on this theta value, that is the change in power level in time. Okay, so please try this question now. I am giving 1 minute to try this question again. I got one answer from the Polash, that is the A, B, C, D, F. Any other answers? Omar, Gomez, Pradyuman, please try. At least you try. If the question, the answer is wrong also. Okay, Omar, A, B, C, D, F, same answer as a Polash. Okay, at least somebody is trying. That is a more fruitful situation than anything else. At least try. Give incorrect answer also, that is fine. At least try. Okay, let's come to the solution part. Regarding this ramp rate, if you see this figure which I have shown you in the right side, this is figure A and figure B. If you see this ramp R star, I have taken from this one paper, that is a 10 watt per second. That is the actual, that is, if you see this, there is a available power, that's the black curve, and this power which is needed, this PV generated power, that is, if there is a 10 watt per second, then this is the ramp rate of this PV. Gomez, you can turn off your mic, please. Gomez, please. Okay. Coming to the first statement, that is a ramping in power plant refer to the gradual change in power generation level. Gomez, please turn off your mic. Thank you. Ramping in the power plant. Coming to the first statement, that is a ramping in power system refers to the gradual change in power generation level over a specified time period. Actually, that is correct, which I have shown in the previous slide when I was explaining this ramp rate. Coming to the second part, that is a ramping event in power system can impact the system stability and reliability of the grid. That is also correct, because it can impact when the power generation demand is higher, but you cannot ramp up to a certain level at which you can meet this demand. So then this stability and reliability problem will come. Coming to third statement, that is ramping is more pronounced in the power system heavily reliant on the stable and consistent energy resources. Actually, that is false. Why? Because ramping is not very pronounced in the power system which is heavily reliant on the stable and consistent energy sources. If you see in the figure also, I have given the figure of this PV power. This is not a consistent energy source. This is not a consistent energy source, but the concept of ramp up also comes in this. So it is not, this statement will not correct in the sense of this power generation. So as option C is incorrect. Coming to D part, the integration of the renewable energy sources such as solar and wind can contribute to increased ramping challenge in the power system. That can. Okay, this option is correct, because it can ramp up to a certain level, because if you have an energy storage system also with this solar generation power plant, then during the demand, the increase in demand power, then battery storage can supply this power to this demanded power and ramp up this power which is needed. Coming to the E part, that is the ramping events are only relevant for the power generation, do not affect the consumption side of power plant. That is false, because you have to see this demand side also, no? The how much you have to ramp up depend upon this demand also. So this option is correct. Coming to the F part, that is mitigating ramping issues in the power system often involves the use of energy storage system and advanced grid management technology. That is correct. So the if you see, the Polar's answer is correct, but only the C option is wrong, and the other also, the Gomez option, Omar, also this correct also, but few the statements are wrong. Okay, this is the concept of this ramp rate. Coming to the next part, that is the capacity firming concept in the power system. Capacity firming, let me give you one example, that if you see the farm, what is the need of this farm? What you do, you have a certain kind of field where you plant these seeds and you get output as a certain plant. Okay, so you have a seed and you are planted in the field and you get a certain output of this plant. Same is kind of this energy storage system also. When you have a generation, higher generation, you can form into this certain energy storage systems, and you can use in the when the demand is higher. When the demand is higher, then you can use this energy storage system. That is the concept of the capacity firming. Please see the statements which I have given, that is 6 statements are there. and tell me that which options are correct and which are false. Just read the statements itself, you get the clarity of certain things. Okay, Pulas is saying A, B, C, E, F. A, B, C, E, F. Okay, A, B, C, E, F. Okay. Okay, any other answers? Gomez, Devendra, Shima. A, B, C, E. Correct. Rajesh is saying A, B, C, E. Okay. A, B, C, E. Any other answers? Omar, Devendra, Seema. Any other answers? Okay, Omar is saying also saying this A, B, C, E, F, same as Gomez and Polash. Any other answers? Okay, let me come to the solution part. Okay, read the first statement, what it is saying. It is saying that it refers to the process of increasing the maximum potential output of the intermittent renewable energy sources. If you see, that is true, no? Why you need this energy storage devices to be placed during with this renewable energy sources? Why? Because you know this energy resources, this RE based resources are intermittent, and you need to dump this extra power during this demand when the generation from the renewable is lower. So it also helps in this maximum potential output, increasing the maximum potential output of this renewable energy sources. That is first option is correct. And coming to the second part, that is the B option, that is energy storage system play a significant role in capacity firming, storing excess energy during the period of the low demand for later use during the high demand period. That is also true. Why? Because when the generation is high, you should store that for meeting this higher demand periods, that is the peak periods. That option is correct. Coming to the C option, that is capacity firming is primarily concerned with the ensuring a steady and reliable power supplies during the times of the peak demand. Actually that is false. False in what sense? Because it is not the specific to this peak demand. This capacity firming is not specific to this peak demand. You can also use it in the off-peak demand also. Off-peak demand also. So this statement is primarily saying this primarily concerned with this ensuring a steady and reliable power supply. That is false. Coming to D part, that is the intermittent renewable energy sources such as solar and wind do not require capacity firming. That is false, because they require. The goal of capacity firming is to address the variability and uncertainty associated. That is true. Capacity firming strategies involve increasing the overall capacity of the power plant to accommodate fluctuation and demand. That is true. Okay. If you have any doubt in these statements, please feel free to ask me. Open your mic and ask me. If you have any doubt. If you have any doubt, please ask me. Open your mic and ask me. Okay, if you don't have any doubt, let me come to the other part, that is the deck curve. It is also a very much important concept, that if you see the curve also, it is looking like a duck. This is an example of this electricity demand in California, what has been observed in the California. Because in California there were certain policies that in which they are placing this solar power plants, solar PV power plants in a huge amount. Okay, so what happened? There was a situation created. A situation. This curve, if you see in the x-axis, that is the megawatt level power demand. And coming to this, and this x-axis is the time duration. If you see this in the upper level, that is 9 a.m., 12 p.m., 3 p.m., 6 p.m. So what happened? They installed a very huge amount of this PV panels in 2019. So what happened during that period? So the power what is demanded, which got lower down. Why? Because if you see this 9 a.m. Power point, this irradiance is getting increased. It increased to the 12 p.m. and it again fall down to a certain level during the evening. So there is a afternoon peak will be there in this solar PV generation. So what happened to level to this? So power which is demanded from the grid lower down further level when the solar PV is at a peak. Then when the solar PV generation lower down in the evening hours, then you need the generation from the grid. So the grid power, the demanded power will again go on increasing at a 6 p.m. and it again fall down when the generation is not demanded at a certain level. So this curve, what this curve shows. So if you increases this PV generation at a huge level, so demand from the grid lowers down. Demand from the grid got lowers down. So what happened to this? So in that time frame when the demand from this generation, these power plants are very low, what will be the two options? You can reduce this generation from these power plants, or you can stop the power generation. So we cannot stop the power generation. Why? Because you need a certain time to again start this power plant. So you need a sudden ramp rate. If you see here also, the ramp rate is very high during the evening hours. So you cannot do such kind of things. You need a certain time to start a power plant. Then you can ramp up to a certain level which is demanded. So as the year increases, that is 2019 to 2020, 2022 and 2021, if you see this power generated demanded from the grid during this morning peaks, that is afternoon peaks, it further lowers down. That also created a situation that whether how to operate this conventional or the existing power plant in what sense. So that is a kind of duck curve. If you see the shape also, it is looking like a duck curve. That happened in the California. Okay. So here also what they have said, that you can use this energy storage systems to store the extra power which is generated during the afternoon peak, and then maintain a level of demand from the grid also. So the power plants also, which is conventional power plants, would operate in a regular fashion. So you need not to sudden ramp up your power plant, the generated power. That is, you should not this steep power ramp rate. Okay. If you have any doubt related to this duck curve, please feel free to ask me. If you have any doubt related to this duck curve, open your mic and ask me. This case study was based on this electricity demand of California, and in India also, if you are implanting a large amount of this solar PV plant which is feeding to the grid, which is grid connected and feeding power to the grid. So in India also there will be one situation will come, no, where the demand from the grid will lower down. In that sense, what you will do, we are not ready for this, because in the this conventional power plant needs a huge amount of time to start up and then ramp. Okay, is there any doubt related to this concept? Okay, let me further move down to one example. This example is related to the investment difference, which I have shown you this need of this energy storage, need of this energy storage, during the need of this energy storage. So what do you mean by this investment difference? This is, there is a one concept of this V2G. G2V, you all know that is, if there is a EV, you can inject the power to charge this battery from the grid. That is G2V. What is V2G? V2G means you can feed the power from the electric vehicles to the grid during the peak hours. Okay, this is the concept of V2G. So what I have written here, because if you see this widespread of EVs lead to extensive integration of the charging station, because when you are feeding this EVs into this charging this grid, because if the large number of EVs increases, EV demand increases, then the generation, this charging station also get increases, so the power which is demanded from the grid will also increase. So this, if you see, this is directly proportional to the EV demand. So what it will cause? It will cause the various issues such as under voltage, increase in peak demand, power quality and reliability. Why? Because if you see the how a normal person works, he works morning, he go to the office at a 6 a.m. and works in the office till 6 p.m. and come back in office. So he will, when he will charge this EV, he will charge the EV before 6 a.m. or at 6 p.m. when he comes to this, his home. So what happens to this demanded power, that power which is demanded? So this demand power, this evening peak will come. If you increase this EV also, this it will further got increased. This demand, this peak demand during the evening hours. Okay, that's created a huge, they demanded a huge investment for this grid upgradation, because this peak demand is getting increased. And who will supply this? This supplies by through your transformer itself, because if there is a LV line connected, so that is connected through a transformer beforehand, before connecting to this higher power supply. So this transformer has certain loading capacity related to 70 to 75% of this loading capacity. If you are increasing further with the EV integration, this loading will not sustain, it will further go on increasing to 80 to 85%. What will happen to that situation? Your transformer will burn and not able to supply this EV demand. So what you will do in that sense, you increase the rating of this transformer, at that particular situation. That what it will need the certain amount of money. Who will going to pay this money? That is a question mark. Because if you see, the major discounts are in loss making. So if you say them to further increase this transformer rating and upgrade this transformer, so they will not put the money, because you are connecting EV into the grid. So that is a kind of a difficult situation to how to tackle this situation. So there the concept of V2G comes. I will explain this concept of this V2G. Let me take a new slide for this. Okay, so if you see, this is the power versus time curve, power versus time. So this is the normal power, that is the average power. This is the average power. So this average power will move like this. This is the evening time, that is 6 p.m. and this is the morning peak, that is 6 a.m. So what happened to this V2G concept, smart charging concept? What this vehicle will do? You connect an EV to a charging station and leave. What happened? This EV will inject this power during the peak hours. So what will happen? This evening peak, this peak will lower down to that level, because a large number of EVs are already supplying this power during this evening peak. And you can charge the vehicle when the peak is not there, after this 8 p.m. or in late night 2 a.m. kind of time. If you are charging here the EV, the power demand will actually lower, but if the power will increase to a certain level, that is not that much, which is similar, which was there in during this evening peak. So this vehicle to grid concept will help in that sense. Okay, is there any problem with this concept which I have explained? If you have any doubt, open your mic and ask me.
Can you repeat it, please?
Okay, sure. Okay, let me repeat this again. Okay. What I am saying that there is certain kind of load curve is there, which is seen in the grid point of view, that is power demanded, power which is demanded, power demanded from the grid, and time. If I scale it down into that is 1 a.m., 2 a.m., similar to this 6 a.m. and related with the 12 a.m., then 3 p.m., 6 p.m. and further it to 12 p.m. and further. Okay, so what the load curve will look like? Load curve will look like this, because in the morning there will be very less power demand, and during the morning when the people will go to the work during the morning time, the power generation will increase, power demand will increase. Then it got further down where, because the most of the people will go on work and not using this energy at a very high level. So what will happen when the person will come back from this office or anything? So in the evening time, this power demanded will again got increased, and it will lower down to as the time increases. So what I am saying, when you have a large amount of EV, that is a large number of EVs, because your grid is not capable of this, not made related to this EV, no, this is a new concept which is EV coming into the market. So if the EV is increasing, so power demanded for charging will also go on increasing. Okay, so what will happen? I have told you that there is a concept of V2G, that vehicle supply the power to the grid. How this will help? You connect your EV for V2G service from the vehicle to grid service to this evening peak time. So this evening peak will reduce, because the extra power which is demanded will come from the vehicle itself, which is a generating source during this evening peak hours. And you can charge your vehicle during the off-peak hours. Off-peak hours means when the energy demand is very low. So this is the extra power which is used for charging, that is G2V. grid to vehicle, and this is the extra power given by the vehicle during this V2G operation in the evening peak. So what will help down? It will help down in reducing this loading on transformer, which will further reduce down this grid upgradation demand. So you should choose that you should take certain time to invest in the grid upgradation after few years, because this is the investment deferral, because you have the EVs which is capable to generate electricity during the peak hours itself. So you don't need to invest that extra amount of power for extra amount of this money for the grid upgradation in this concept. So it's a kind of investment deferral. I hope that I have explained you.
Yeah, got it.
Okay, thank you. So this is a concept of V2G which is currently new in the Indian scenario, and it is also a kind of advantage also for this investment deferral. Okay, coming to this classification of energy storage system, you have already studied that there are certain different types of energy storage system, that is mechanical, electrochemical, chemical, which we have seen from the question also, which I have shown you in the further previous slides. A thermal and hybrid waste system. I have explained this hybrid concept also. So depending upon the demand level, variety of this demand level, and this discharging time and discharging capacity, there are different kinds of energy storage system which can take place, and it also depend upon the location. There is a location is also one of the constant for this energy storage system. Okay, coming to the next slide, that is a comparison of this key type of energy storage system. If you see, I have given x-axis. If you see the system power rating or the module size, and in the x-axis you can see this discharge time at a rated power. So if you see from this slide, this nickel cadmium and the nickel metal hydride based it have a lower this discharging time, which is very useful, because if you have a discharging time of in milliseconds or certain minutes, you can use it for the sudden ramp reduction of this demand. Okay, and this also classified in form of this reserve and response services, transmission and distribution support services, and the bulk power management. And there are different kinds of energy storage system which is classified depending upon the system power rating and discharge time, and depending upon this reserve and response services and transmission distribution and the bulk power generation. So a variety of this energy storage system are there, which can be utilized depending upon your requirement and what is demanded. This is one question which I have shown you, is depending upon this what kind of energy storage system which is used for the what application. You have to match from the left side to right side depending upon the application of this energy storage system. Please try the question. You can use this energy storage systems for other applications also, but this is the majorly application based sources, that this supercapacitor is mainly used for which kind of services. Okay, that is the main concept to put this question in favor. Any try, any guesses, any answer? Okay, Pulash is saying that for D, third A, second C, fourth of D, third of A, second of C. Okay, then we saying third of A, which is similar as Pulash. Any other answers, guys? Okay, then we say fourth of D, that is similar to this Pulash. Okay, nice, keep trying. Uma, please try. At least you should try. Then we say A of E. A, E. Okay, means first of E. Okay, let me come to the solution part. This is depending upon the slides also which are provided in the NPTEL itself. There it was written that mainly which types of energy storage system is used for which application. So it is how it is matched. It is matched directly. This is first of A, second of B, third of C, fourth of D, fifth of E. That is the correct solution. That this supercapacitor and flywheel based applications are for the grid stability and the UPS. And lithium ion is a stationary kinds of storage system which is used for this various stationary applications. Okay, and lead acid is mainly used for this UPS. If you see, if you have the UPS, you can see that this is lead acid kind of batteries which is used. And redox flow batteries are used for large scale storage with large long discharge time. This is a correct match. Okay. Coming to the next question, that is related to this battery energy storage systems. I have given the 4 statements. You have to tell me that which options are correct depending upon this battery energy storage kind of system. BES means battery energy storage system. Please try this question. Have been saying all are correct. Okay. Any other answers? Pulaj is also saying all are correct. Okay. Any other answers? Go to the concept of this battery energy storage system. Please read the statements carefully. Any other answers? Deven, please try. Seema, please try. Tanya, please try this question. Gomez is saying ABC. It means that D is false. Okay. Good. At least you are trying. Any other answers, guys? One more answers from Seema, from Devin. Anybody? Okay, let me explain this concept. Okay, coming to the first part. that is the batteries fit best to the decentralized applications due to their flexibility and ability to store from minutes to multiple hours and from few kilowatt to multiple megawatt. That is correct. Why? This is a decentralized application because you can use this battery energy storage system at a different location. You don't have to operate at a centralized manner. You can use depending upon a particular node. If at a particular node energy demand got increased, you can use to inject the power at a particular node itself. That is a kind of decentralized application. Coming to the B part, the lithium-ion batteries are mostly preferred because of their high energy as well as power density and low safe discharges, no memory effect and large life cycle and the low cost. This statement I have taken from the various sources because if you do not find these keywords at a particular statement. So it have the high energy density, that is correct. It have the high power density, that is also correct, and it have low self discharge rate, that is also correct. This I will explain in the further slide. What do you mean by this self discharge rate? No memory effect. No, what is mean by this memory effect? This means that this lithium ion batteries have certain path to follow when they turn on. Suppose this is the rated voltage of this battery, so it will move from this voltage to meet to this maximum Vmax to min. This is from the 0% SOC to 100% SOC. We don't operate from the 0% because we give certain limit, that is 20% to 80% limit, due to the avoiding the situation of this overcharge or over discharge. So this battery will follow this path for charging. So if you keep on charging, suppose you have done with 100 cycles, so it will recognize this path, that it will charge from this path only. It cannot follow the charging rate which is higher than this voltage level or lower than this voltage level. So it makes a path due to the force of these electrons during the charging process. So that is concept of this memory effect, that it recognizes the path of charging. So there is no concept of memory effect in this lithium ion batteries, and it also have the large life cycles and the low cost. That is also correct because if the energy density increases, the cost will reduces. Coming to the C part, that pump hydro is energy shifting concept, and second one is the peak saving concept. What do you mean by this energy shifting? Energy shifting means you should shift this energy use to some other time frame. What do I mean? It means that if you see there is certain black curve is there. If you see this black curve and this black curve, it means that if you are maintaining a certain power level, store this extra power which is generated during the low load period and discharge this energy during this peak hours. If you see this upper level, this 2 and 3, this is the peak hour. Discharge this energy. So what do you mean by this? This load curve, if you see that the demand is very low, but here at two positions, at this position, these two positions energy demand is high. Discharge your energy storage system during this peak hours. Discharge your battery during this peak hour. That is kind of energy shifting. It means that you are storing its power during the low load period and discharging during the peak hour. That is a kind of energy shifting. Coming to second concept, that is peak saving. Peak saving means when you are charging this battery charging from VES charging from this generation. So you are charging this amount of power to maintaining this a constant level of generation, and you are discharging during the peak hours. You are shifting this peak to a lower level. So that is kind of peak saving. You mean that you are reducing this peak to a this level. You are discharging this extra power during the peak through this battery energy storage system. Okay. Am I audible? This energy shifting and peak saving concept is there. Energy shifting means you should charge the battery during the off peak hours and the low load condition, low load time frame, and you should discharge this power during this peak hours. And peak saving means reducing this peak, this extra which is peak which is demanded, lower down this peak to a certain level, that is the peak saving, by discharging the extra power. So this is the two concept, very important concept of this energy shifting and the peak saving. Coming to this general model of this energy storage system, if you see from the right hand side, this is the stored energy, that is the ideal storage system, and it have a certain losses based on this discharging or the charging, which is depicted in series with this storage energy. Why? Because energy will reduce down to a certain level which is taken by this stored energy, that is the energy minus energy loss. Okay, so it is connected in series fashion. Or there are state is given. State means there are three types of state, that is charging, discharging, or ideal condition, when there is a no charging or discharging is happening. As certain idealing losses. Ideal losing is such that when you place this battery energy storage system for certain time duration, such as months or years, so the capacity will fall down. Its capacity of the battery will fall down. That is known as the capacity loss. And after that, you should convert this DC energy to AC using inverter and fed back to the grid in form of reactive power or real power. That is the general model of your energy storage system. Okay, are you getting my point? Okay, let's come to the other concept. This is the concept related to the battery degradation. Battery degradation. I have given you the 4 statements related to this battery degradation. You have to tell me that which statements are correct related to this battery degradation concept. Saying B and C is correct. Any other answers? The last is saying A, B, C, D is correct. Okay, there is a catch in this question. Please read the statements very carefully. There is a slight catch is there. No, all are wrong. Okay, that means saying that all statements are wrong. Any other answers, Seema? Kanya, Bhumesh, any other answers? I'm giving 2 minutes of time to solve this. Sumesh is saying A and B. Okay. Let's go to the solution part. Let's jump to the solution part. If you see from the statement that battery aging is a linear process that depend upon the time, temperature, depth of discharge and number of charging and discharging cycle. That is false. Why false? Because it's a non-linear process. It's a non-linear process because you get this SOC versus voltage curve, voltage versus SOC curve in a non-linear fashion. So that means that it is dependent upon the time, that battery aging. If you keep on charging, discharging through this SOC cycle, so this your degradation, battery will degrade. So it is a non-linear process. And coming to the B option, that is a cycle aging is defined as the inherent degradation over time. Over time, the rate of degradation depend upon temperature and SOC. That is false. Why false? If you see this B and C statement, I have interchange. Interchange in what sense? That B statement is regarding this calendar aging and C statement is regarding this cycle aging. Cycle aging means if you keep on charging, discharging a lot of number of times your battery, then your cycle life of the battery will degrade. It means that it terms as cycle aging. That is depicted in C statement. In the B statement, it is calendar aging. Calendar aging means if you kept this battery and you are not using it for several years, its energy will drop down. It will degrade. It will degrade, but the rate is low. Rate is low depending upon this cycle aging, but it will degrade. And coming to D option, that is also false. Why? Because the ESS, the energy storage lifetime, depend not directly proportional, it is inversely proportional. Means all statements are false. It means that if the degradation increases, energy storage lifetime will decrease. If the degradation is low, then the lifetime of the energy storage system will be high. Okay? So it means that all statements are false. Here I have given the certain concept of this battery degradation, that if you see here, this is the copper current collector. Okay? The basic idea is you have this anode, you have cathode, and in between you have separator, and this anode is connected to certain external terminal through gasket. Okay, this copper current collector is, and this is aluminum current collector, that is, this is the anode and this is cathode. So this is made up of certain material, so it means that it will also degrade based upon this time frame or other thing. So when the lithium ion percolates inside this graphite layer, it will also create a crack inside of this. This is, if you see this particle cracking phenomenon, this is a there is also structural disordering, means one structure of this cathode will move down to some other place. Also said there is a SCI layer formation, there is a salt aggregation, because there are certain amount of materials are there inside of this, so they create a layer that is known as solid electrolyte interface. We don't need to go into depth, but you can think of that every element inside of this battery system get degraded over time or based on this cycle. Okay, how this due to this cracking, or this is particle cracking or particle loss. Okay, coming to this capability curve, which is very important. Why important? Because if you have a certain power plant, how much power you can get from this, it limited. How much reactive power you can supply is limited. So capability curve means I have given the two curves, PQ curve at a constant power factor, first curve, and second curve with the constant reactive power support. So if you plotted between this P and Q at a constant power factor, this phi is constant. If you see, this phi is constant. It means that if you increase this P, increase the power, this Q will also getting increased. Why? Because if you see this tan phi is equal to this Q by P constant. If you are increasing this P for maintaining this ratio constant, if you increase this Q, then you have to decrease this P. Okay, here it is in negative. Okay, if you are here, you are decreasing this P, means your negative power is there, then you should increase this Q in positive side. Okay, and in the right side you are maintaining a constant Q, means your power plant is sufficient to give a constant reactive power supply as you are increasing this power. What happened in this situation? If the point 1 is your first Q1, at that point you have certain P1 and the power factor is phi 1, and you have ramped down to this Q2 location where you need this Q. Here Q is constant, so Q1, so P will increase. What it means? It means that tan phi is equal to Q by P. Q is constant. It means if you are increasing this P, this power phi will decrease. Tan phi will decrease or power factor will increase. Okay, that is the two kind of capability curve, depend upon what kind of, how much amount of Q or P you can support to the grid, give the support to the grid. If you have any doubt, you can ask. Okay, let's go to the further slide, that is the ECM based model. Because if you have a battery, it is a combination of cells, that is the combination of cells, and these cells are connected in series or parallel depending upon what your application, what your voltage rating, what current rating will be. So if you represent this cell with this ECM model is that you have OCV. OCV means cells internal voltage. Which depend upon this ZT. ZT is SOC. How? I have shown you this curve. This voltage will increase from certain lower limit to higher limit depending upon this SOC. So this voltage is function of this SOC. This is the internal voltage, that is the OCV, which is function of this ZT. Okay, and one is the hysteresis voltage and other is polarization voltage, and next one is R naught. What is the hysteresis voltage? This hysteresis comes with the concept of this charging and discharging of the cell. This charging or discharging of the cells do not follow the same curve when the voltage increases from a certain SOC level to a higher SOC level. So the difference between this charging and discharging curves is known as hysteresis. This hysteresis is represented by this HYST, which I have shown in series combination. What do you mean by this diffusion? Diffusion means if your voltage is maintained at certain level and you sudden discharge your battery, if you are sudden discharging your battery and leave that at a level, then the battery will take certain time to settle down to a certain voltage level after discharging. So that effect is known as diffusion. That is represented through R and C combination in parallel. And this R not depend upon this temperature. Why? Because during the charging, charging means your voltage, which is terminal voltage, should be less than greater than this OCV ZT. It means that certain impedance will be there inside, and during the discharging when VT is less than OCVT, it means that your current is positive but voltage is less than. It means that this voltage drop is coming inside of this battery, that is represented with this R naught. Okay, if you have any doubt you can ask, otherwise you solve this question related to this battery management system. This question related to battery management system, please try this. There are 6 statements are given. You have to tell me that which statements are correct. Any answer? Okay, Gomez is saying B, C, D, E. Last is saying V, E. Any other answers? Dharmi, Pranya, Devendra. Any other answers? Okay, let's come to this solution part. If you see the first statement is saying that a battery management system is primarily responsible for physically manufactured battery. If you see this physically manufactured battery, and the statement seems to be wrong. Why? Because the BMS is not involved in this physical manufacturing of these batteries. Because once the battery is being made, this battery management system then installed with this battery. Okay, so it is not responsible for the physically manufactured battery. So first statement is false. Coming to the B statement, that is BMS is crucial for monitoring and maintaining optimal operating condition within a battery. That is true, because the battery voltage should not increase from the rated value that is maintained, so it should not overcharge or over discharge, and it should not explode when the temperature rises. So you need a certain cooling system also inside this battery pack. So that is responsible for this monitoring and maintaining this optimal operating condition. Coming to C option, that is BMS plays a minor role in protecting batteries over overcharging, over discharging or excessive temperature. That is false. It plays a major role, not minor role. It plays a major role. Okay. Coming to D option, main purpose of BMS is to maximize the energy density of the battery regardless of their application. That is false. Why false? Because when the battery is being made, that this energy density depend upon this chemistry. Density depend upon the chemistry. So how can a BMS can help in increasing or changing this chemistry? So it cannot maximize this energy density. It is already been manufactured. Coming to E part. E part means BMS is essential for balancing the individual cells, ensure the uniform charging and discharging. That is correct. You should not charge a cell from a higher level than the other cell. It is balanced using some balancing circuit, which I will explain in the further slide. And the BMS is only relevant for the lithium ion batteries. It does not apply to other type of rechargeable batteries. That is false. It is applies to the other type of battery, nickel cadmium, aluminum air, or any kind of battery. The BMS can find an application inside of this for the protection and management. Coming to this BMS, what is this BMS? This IEEE standard that 1889 defines the BMS as a system that includes active functions necessary to control activities such as charging, discharging, and thermal management and safety. And it also monitors the state of the secondary batteries, compute subordinate data, communicate the data, safeguard the battery, and regulate its surrounding and balance it. It means that it have the communication feature, safety feature, data storage facility, and data communication facility, and computation also, which is done through this microcontroller, which command is given through BMS. Okay, that is the main concept of this BMS. And BMS contains, if you see the right side figure, it have battery monitoring system, battery modules, current sensors, voltage sensors, and other kinds of equipment also. Okay, if you have any doubt, please ask me. If you have any doubt, please ask. Okay, let me move to the further slide. That is the evolution of this secondary or rechargeable battery or cells. If you see, there are certain chemistry, that is lead acid chemistry, nickel cadmium. C stand for cylindrical and P for prismatic. And nickel cadmium, lithium ion, lithium polymer. So as the volumetric energy density is got increasing. What do you mean by volumetric? It means that what amount of energy, that is watt hour energy, you can keep or store in 1 liter of this solution. 1 liter of this solution. And gravimetry means how much watt hour you should store in 1 kg of this. That is the two kinds of system, that is gravimetric and volumetric kind of system. Okay. So there are three kinds of cells, that is cylindrical cell, prismatic cells, pouch cell. If you see the cylindrical cells also, it is of a smaller size as compared to this prismatic or pouch cells. Prismatic is a hard casing is there. If you see, there's lead acid batteries, that is prismatic kind of cells. This is the which you use at your home also. If you see the casing of your battery, it is very hard. That is the prismatic kinds of cells. Pouch cell, which you can pouch. What do you mean by this pouch? Pouch means you kind of you can store in your pocket itself. That is a soft casing is there, and larger size and high individual cell capacity, and the deformation and the geometrical deformation during the discharging also takes place. So there are three kinds of cell, that is a cylindrical, prismatic, and pouch cell. And in the left side figure, I have explained that as you are increasing this volumetric energy density, this gravimetric energy density of the cells is also increasing depending upon this chemistry. Okay, so the lithium ion batteries, which are mainly being used cylindrical type, or it have a higher volumetric and gravimetrical energy density. So that's why it is says that it have higher energy density and power density. Okay, coming to this SOC concept, what do you mean by the SOC? If you see in the center figure, this is a graphite layer, graphite lattice. Graphite lattice means this is the places at which you can inject or place the lithium ion. So this theta k is the average amount of lithium ions which can be placed inside of this graphite lattices, and divided by the maximum amount of this lithium ion can be placed inside of this lattices. So if you feel here in the figure, the two lithium ion are in black position are being placed, but how much you can inject, that is 1 2 3 4 5 6 7. So that is the theta k. And what is SOC? SOC is this theta k minus theta 0% divided by theta 100% minus theta 0%. So that is the SOC. So 100% means all the lithium ion being placed in this graphite lattice, and 0% means no lithium ion being placed. That is the correct definition of this SOC. Okay, and in the right side figure, in the third figure, I have explained that how this theta 0% to 100% being told in this battery environment, that this is the 100% SOC. SOC is 100%, and the CS max is achieved. Any doubt? If you have any doubt, you can ask me in between. There is no issue with me. There are 3-4 slides are left. After that we will finish this, and one numerical problem is also there. So this SOC estimation, there are different types of SOC estimation methods are there. First one is the OCV bed. What I have explained in the OCV means voltage versus SOC curve. If the SOC increases, the voltage also increases. So at a particular point of SOC, if the voltage is being measured, you can tell that this is your SOC. So this is the OCV based method, that you have the data of this voltage and corresponding SOC also. So if you keep the voltage at a particular value, then the SOC is predicted from this lookup table. Second one is this Coulomb counting. Coulomb counting, that is a ampere hour integral method, that the how much amount of this charge is being accumulated. And other methods are there. There is a model based, that is the EIS method, ECM method, electrochemical method, and the data driven methods also. That is data driven, that is neural network, ANN based, SVM based, that is the different kind of thing. But mostly what is being used is Coulomb counting and model based estimations. That is the most important. And coming to a very important concept of this SOH, that is the health of the battery. If you see this curve, in x-axis you have voltage, in the y-axis you have this capacity curve. If you see this, if you keep on charging and discharging, means from the first cycle when you charge or discharge, then the battery will follow this red curve. Red curve means highest capacity. When you increase this cycle level, the 63 level, yellow curve, the capacity drop down to a certain value. If you further increase this cycle, then it will further drop down. If you increase to 100 cycle, then it will further down. So reduction in the capacity of this battery is known as this health of the battery. Is a one of the parameter to measure this health of the battery. Okay, this is the health of the battery, means reduction in the capacity depicts this health of the battery. And you also have certain other methods also, this SOH estimation, that is a direct method, indirect method. Direct method means capacity measure. From this curve, if you measure this capacity, you can predict the health. Or you measure the internal resistance. Internal resistance means R0 value, which I have told you. Impedance measurement means certain OCV curve is there, you measure this impedance, what is there, this impedance will increase, the battery capacity or SOH will decrease. due to the heating effect. And certain other indirect methods are also there. There are model based, data driven method, hybrid method also, that is the ANN or CNN based methods. Coming to this concept of this unbalancing, suppose there are two types of unbalancing, that is passive cell balancing and active cell balancing. Passive cell balancing means you are using if there is a imbalance, so you should discharge the highest battery cell energy to a level of this lower level cell battery level. If you see in the figure, I have given the cells as B1, B2, B3, B4. So B1 is being discharged to a level to B3 to maintain the charge level till B3 after the passive cell balancing. So how you are dissipating this extra energy? Through an external resistor. So you should dissipate this extra energy across this R, that is the I square R loss will takes place, and this drop down to a red cell level, that is the passive cell balancing. What you do in the active cell balancing, it should make a optimal level, means you should not discharge to a level of lower level, you should maintain a certain above level between of this battery level, that is the average value of this B1 plus B2 plus B3 plus B4. After that you should discharge to a Z level. That is a kind of this cell battery technique. That is two types, active and passive cell balancing. This is a question which you should solve. This is a numerical based problem. Please solve this question, that is very important. Please read this question first. Please try to solve this question. After that I will, let me explain first. Assuming this linear relationship between the SOC and battery voltage, it is saying that there is certain curve in between this voltage versus SOC, and it is saying that at 0% SOC it is maintaining at 2.7 volt. After that it increases linearly till 100% SOC, and voltage at 100% SOC level is 4.3 volt. What it is saying that it is maintained the voltage level at 3.5 plus x percent. So you have to tell me what is x. If you see this 3.5, it is a midpoint of this voltage level. It is midpoint. It is 4.3 plus 2.7 by 2, that is 3.5. Plus x percent during the charging, minus x percent during discharge. That is the nominal voltage. Find out this x. First find out this voltage versus SOC equation, that is y is equal to mx plus c kind of equation. After that you can find out this. Being saying 81.39 x, okay, 81.39. Let's other person please try. X percent the change. If you see going from 3.5 to 4.3 or lowering down to 3.5 to 2.7, from the percentage also you can find out. counselors? Okay, let me explain the first part. After that you should try for the B part. If you are trying, please write in chat box that I am trying. I will wait for a few minutes. Okay, let me explain the first part. Okay, what I have told that this voltage versus SOC curve is such that it is charging from this lower voltage level, that is 2.7 volt, to 3.5 volt at a 100% SOC level, that is 3.5 volt. This is 0% SOC and this is 100% SOC. So at the center you have a voltage that is 3.5, and you have to tell me that this charges to 3 plus X% and this charges to a voltage that is 3.5 minus X%. You have to find out this X. If you see this X moving from this 3.5 level to 4.3, how you find this X? This X is equal to 4.3 minus 3.5 divided by this 3.5. This is a only percentage, no? Because you are moving from 3.5 to 4.3. You have to find out what is the change percentage. That comes out to be 22.85%. If you see lower from, if you are moving from 3.5 to 2.7 level itself, in this case also X will be this 2.7 minus 3.5 divided by this 3.5. It comes out to be minus 22.85%. So what will be the X? X will be this 22.85. Okay. So how you find this B problem, that associate a particular value? That will be find out using this y is equal to mx plus c equation. That is y is, what is y? Y is here voltage is equal to m times of SOC plus certain constant. If you find out this equation, it will come out to be 0.016 times of SOC plus 2.7. So in the second problem, what it is asking that SOC at 4 volt. So if you put this V at a 4, you can find out this SOC. And same with this C problem, that if you put the SOC at 0.64, you will get this voltage itself. So that is the major sense of this problem. Major sense. Coming to a last problem. This is the last problem, and this is also a important depicting the important concept. If you try, that is a very short solution based problem. If you use Dharmi is saying 3.5 is the X is getting 50%. I am saying please try once more, Dharmi, then you will find out this how this 22.85 is coming. Try this problem 13. We will discuss this 12 question in further discussion. Okay. Try this 13th problem. That is also important problem. Okay, due to the time constraint, I have to explain. Anybody trying? If anybody trying, please let me know. Otherwise, will explain. I will share this slide. Let me try explain the solution, and you should try by yourself after this. Okay. Please see here what I am saying. This is the solution part which I am explaining, that it is saying that you have an initial SOC of 60% in the battery, and you have a charging current of 500 milliamps and the charging time of 200 hours. So the total charge added during the charging calculated with this current multiplied by time, that is the Q is equal to IT. What will come? That is a 500 milliamps which is being charging current, and for 2 hours that is 1000 milliampere. So what will be the new SOC? Because it is charging, so initial SOC will be 60% plus 1000 charge being added to rated capacity is 3000 multiplied by 100. This come out to be this 93.33% when it will charge. When it will discharge in the cycle, the discharging current is 200 milliamps and discharging time is 1.5 hour. So total amount of charge being taken from this battery is 300 milliampere. So how the new SOC will change? Now the new SOC will be 93.33 minus 300 divided by 3000 multiplied by 100. What it will come? It will come to 83.33%. This is the concept, that how much charge you are adding during the charging, how much charge you are taking during the discharging. That is the main crux for calculating the SOC of this problem. That was the last question. Okay, 83.33. Pulas, you are correct. Thank you so much. Okay, that was the final question. If you have any doubt, please feel free to ask me. Open your mic and ask me. Otherwise, I will end the session. I will share the slides and the video also. If you have any doubt, please ask me. Dharmendra, you were late.
Yeah, good evening, sir. Actually, I have joined late. I forget the schedule.
Okay. No issue.
Really, I
Okay.
missing, sir, your lecture.
Thank you. We will explain, share this video also and the lecture slides also. You should go through, and you have any doubt, you can ask me in the further tutorial sessions. Any other doubt, Devendra?
Sir, when it will upload?
It will got uploaded. There is a link in this NPTEL web page. If you go to the SWAYAM portal, where you see this assignments, in the
Yes.
lower section of that column, you see this uploaded material, that is video lectures, and link is there. So you should go to that link. You will find this video lectures link and this PPT slides.
Okay, thank you, sir. Sir, today lectures regarding the related to third assignment or fourth assignment?
This related to third assignment.
Okay, sir.
Okay, thank you guys. I'm stopping this session. Thank you very much.